Alright, if you've ever wanted a 5 on the AP test, then pay attention to this lesson. Today, we're going to be talking about the first derivative test. Now, we all know what the derivative finds. The derivative finds slope. So anytime we think about the derivative, we're always thinking the slope of a graph. So if we can understand the slope of a graph, we can understand where the function is increasing or decreasing over an open interval. So today we're going to talk about the first derivative test. Next week or later on, we're going to talk about the second derivative and what its applications are. And that's also a very big lesson for us too, but it all starts here. We're going to use something that you probably haven't heard before or that you haven't seen in a while called a sign test. And the sign test is going to be used to determine the intervals where the function is increasing or decreasing. So anytime I'm thinking of the word increasing or decreasing, I am thinking of a derivative, because increasing functions have a positive slope and decreasing functions have a negative slope. And they give us this graph f of x. So this is the graph f of x. This is the function itself. Now later on they're going to change this up on you a little bit, okay? So you got to be careful. So if I want to find out where this function is increasing, this is pretty easy to do. We would say, oh, the function has a positive slope between 0 and 1, between 3 and 5. It's easy to tell by looking at this graph, but we're going to come up with a very consistent way to do this at all times. So, to answer these questions, what we're going to be looking at is where does the slope change direction? And of course, where the slope changes direction is up here at the very top where the slope is 0. Down here where the slope is 0, it becomes positive again, and it stops over here where the slope is 0. So we can find out where a function is increasing or decreasing by looking at where the slope changes signs. And to do that, we're going to find critical numbers. So we want where the slope equals 0. Now later on, we're also going to include does not exist, D and E's in 2. We call these critical numbers. And I can get those, in this case, by looking at the graph. Okay, x equals 1, x equals 3, and x equals 5. Now again, later on, we're going to include D and E's. So now we're going to do what's called a sign test. Now the sign test just basically kind of tells us the signs of the slope. Our domain is from 0 to 6. Now on top of here, we're going to put the derivative. Remember the slope of the graph. Is the slope positive or negative? On the bottom, how does it make the function act? Is it going up or is it going down? And in the middle, we're going to put our critical numbers. 1, 3, 5. And now I look at the graph. Between 0 and 1, the slope is positive, so I put a plus. So between 0 and 1, the function's going up, like a disco duck. Between 1 and 3, the slope is negative, so the slope is going down, like a disco clown. Notice, don't do this. There's a reason we don't do this. We're going to talk about that later on, okay? You really want them kind of slanted. Between 3 and 5, the slope is positive, so the function's going up, like a disco duck. Between 5 and 6, the slope is negative, so it's going down, like a disco clown. And now I can answer my question. Where is the function increasing? And I can answer it. The function is increasing on the domain where the slope is positive, 0 to 1, or 3 to 5. And we're going to put down the reason why. Because we don't say the slope is positive. We don't just say because it. We never say it, so you got to be specific. Because the derivative is greater than 0. In other words, that the slope is positive. Don't say the slope is positive. You have to nerd it up a little bit. Use f prime. The function is decreasing on between 1 and 3 and 5 and 6. Notice I say on, not at. At is at a point. We're on a domain. And that is because this time the slope, the derivative, is less than 0. Now the mistake that people make is that they like to say it's decreasing on the domain because it is less than 0. Well, we don't define it. What is it? Okay? So you got to be specific. Give it a name. The derivative. Now, this was a very easy one. You can do this one without any paperwork, any writing. But in the AP, they don't make it so simple. Let's look at our next example. This says use the sign test. Again, we're going to use the sign test to determine where the function is increasing and decreasing. So again, we're looking at the derivative, but this time the graph is the derivative. So in other words, this graph is f prime of x. So this graph is the graph of the slopes. And this gets a little bit trickier for us because it's not the same. If I were to say where is the function increasing, given the derivative graph, it's not as easy as looking for the turnaround points from 0 to 1. In this case, because this is the graph of the slopes, we have to think of it in terms of the slopes values. For example, our critical numbers where the slope is 0 is going to be along the x-axis. Kind of like right here. My values here are 0. F of x is 0. F of x is greater than 0 above the x-axis. F of x is less than 0. We learned that in Algebra 1. With slopes, it's a little bit it's a little bit different. We're talking about the slopes, not the values. So along the x-axis, the slope is 0. If we go above the x-axis, the slope is positive. If we go below the x-axis, the slope is negative. So when I'm looking for my critical numbers, remember our critical numbers, this is where the derivative or the slope is 0 or d and e. We should always write down d and e here. I didn't do it there, but we can include it down here. Well, where the slope equal to 0, well, I can look at my x-axis. It looks to be at 0, 2, 4, 6. Now, we can include endpoints here because this is the graph of the derivative. We're going to go into that a lot more later on. But it's basically like this. If this is my speed graph, if I'm at a stop sign and I'm stopped at time equals 0, my speed is actually 0. Because they give us the graph of the derivative, we can include the endpoints here. Again, we're going to talk more about that later on. Next, I'm going to do my sign chart. My domain is 0 to 6 still. On top is going to be my derivative. Now notice I want you to write, you should write this out. AP is looking for you to get a 5, so show your work. I put my critical numbers, 0, 2, 4, and 6. And now I want to find out their signs. Between 0 and 2, we are above the x-axis. We are above, and we're above is telling me that the slope is positive. So between 0 and 2, the function is going up, like a disco duck. Between 2 and 4, we're below the x-axis. So we're below. So that tells me the slope is negative. It's less than 0. So it's going down like a disco clown. And then between 4 and 6, the slope is positive because we're above the x-axis. So the function is going up. Notice the function does not have the same necessary direction as the derivative graph does. And now I can answer my question. Where are we increasing on the domain? 0 to 2 or 4 to 6, and that is because the derivative of the function is greater than 0. Where is the function decreasing? On the domain 2 to 4, and that is because the derivative of the function is less than 0. Again, don't use the word it. Now, I know I took a long time to do this, but you'll have this done, all of this work done in less than a minute. It takes less than a minute to do it. All right, so let's go ahead and talk about the test for an increasing and decreasing function. We talked about it up here. It is a lot of work, but let's talk about the definition of it. A function is considered increasing on all x values if the derivative is positive. If the derivative is greater than 0. In other words, we have a positive slope. In other words, the definition, increasing on an interval if the previous point is less than the next point. This just basically says that the values are getting bigger. That's all it means, are getting bigger. For example, I have a function like this. If here is f of x1 and here is f of x2, we can clearly see that the second point is bigger than the first point, or that the first point is less than the second point. A function is considered decreasing if the derivative is less than 0. In other words, we have a negative slope. Again, the definition of an interval, decreasing on an interval if the values are getting smaller. If the values are getting smaller. And we can look at it graphically. If I have something like this, here's my first point, here's my second point. The values are getting smaller as we move to the right. And the last one is called the constant. A function is constant for all x if the derivative is 0. In other words, we have a horizontal slope. Very easy to do. So let's take a look at an example right here. We want to determine if the function x cubed minus 3 halves x squared is increasing or decreasing or constant at x equals negative 2, and then to justify. So anytime they say increasing or decreasing, we know we're going to have to take a derivative. We want to know we're talking about the slope of the graph. So we'll take the derivative, f prime of x becomes 3x squared minus 3x. And I just plug in that negative 2. This becomes 3 times 4 minus 3 times negative 2. And if you simplify that, you get, what's that, 18, which is greater than 0. So my slope here is greater than 0. That means it's a positive slope. Therefore, this is a positive slope. So we know that this function is increasing. And that's what we're going to say. F of x is increasing at x equals negative 2 because the derivative at negative 2 is greater than 0. And that's what you can write for your answer. Show your work, write your answer. All right, go to part 2, and we're going to take a look at some other examples. I'll see you soon. Bye.